Hello and welcome. I'm Andrew Conniff, a technical trainer at Microsoft, and in this video, we're going to continue with infrastructure as code, specifically Azure Automation and desired state configuration. So let's get started. Azure Automation is a powerful service in Microsoft Azure designed to simplify and automate the creation, deployment, monitoring, and maintenance of both Azure resources and those outside Azure. With Azure Automation, you can manage shared resources, automate state configuration, and integrate seamlessly with tools like GitHub and Azure DevOps. This means we can keep our environments up to date, apply updates automatically, and even manage systems that expose APIs over internet protocols. Whether you're working with Windows environments or need to automate tasks across different platforms, Azure Automation provides the flexibility to streamline operations and reduce manual effort. A runbook in Azure Automation is essentially a set of tasks that automate processes in the cloud, making routine operations much simpler and less error-prone. So think of a runbook as a script or workflow that you can create, customize, or even import from a community via the runbook gallery. These runbooks serve as repositories for your automation scripts and can be graphical, written in PowerShell, PowerShell workflow, or even Python. By automating tasks like resource provisioning, updates, or maintenance, runbooks help ensure consistency and reliability across your Azure environment. They can also reference shared resources such as credentials, variables, connections, and certificates, making it easy to build complex workflows that are secure and reusable. When working with Azure Automation, shared resources are the backbone of efficient and scalable automation. These are global assets like schedules, modules, Python packages, credentials, connections, certificates, and variables that can be used across multiple runbooks. By creating and managing these shared resources centrally, we save time and reduce manual edits, making our automation workflows more consistent and easier to maintain. For example, if you need to automate tasks on several servers, you can use the same credentials or variables in different runbooks, ensuring reliability and security across your environment. When working with Azure Automation, the runbook gallery is a fantastic resource for accelerating our automation projects. Instead of building every automation script from scratch, we can import pre-existing runbooks from the Azure Automation GitHub repository. These runbooks have been created by Microsoft and the broader community to help eliminate the time and effort needed to develop custom solutions. We can use these runbooks as is or modify them to fit our specific needs, and the gallery provides helpful features like code visualization, source project links, and ratings to guide your selection. Python runbooks are also available. Just filter by language to find exactly what you need. This flexibility means that you can quickly automate tasks across your Azure environment, whether you're managing resources, updating systems, or integrating with other platforms. In Azure Automation, webhooks are a powerful tool that lets us automate the process of starting a runbook using a simple HTTP request. So instead of manually triggering the automation task, we can set up a webhook, a special URL that, when called, instantly kicks off our runbook. This approach reduces complexity and allows external services like Azure DevOps, GitHub, or even custom applications to interact with our automation workflows. For example, you might have a deployment pipeline in GitHub that needs to trigger a runbook in Azure Automation. With the webhook, integration is seamless and efficient. Managing automation scripts and workflows becomes much easier when you integrate Azure Automation with source control systems like GitHub and Azure DevOps. Source control integration allows teams to collaborate efficiently, track changes, and roll back to early versions of runbooks if needed. So we can push the code from Azure Automation to our source control repository, or we can pull the runbooks from source control into Azure Automation, ensuring that our automation assets are always up to date and auditable. This setup supports syncing different branches to development, test, or production environments, making it simple to manage changes across multiple stages of our workflow. PowerShell workflows in Azure Automation are designed to help automate and orchestrate complex tasks across multiple environments. Built on top of Windows Workflow Foundation, these workflows allow us to define a series of activities, specific tasks that can be run in parallel or sequentially. This means you can automate long-running processes, repeat tasks reliably, and even recover from unexpected interruptions like network outages or server restarts. Workflows are idempotent, so you can run them multiple times with the same outcome, making them ideal for cloud operations where consistency and reliability are crucial. One of the standout features of PowerShell workflows is the ability to be interrupted and resumed, which is especially useful for managing large-scale deployments or maintenance tasks. We can use checkpoints to save the state of the workflow, ensuring that if something goes wrong, the process can pick up right where it left off. By leveraging parallel processing, we can start multiple virtual machines or services at the same time, speeding up operations and reducing downtime. PowerShell workflows offer a powerful way to orchestrate multi-step processes across different environments. Unlike regular PowerShell scripts, workflows are built on Windows Workflow Foundation and require the workflow keyword to identify them. You can add parameter values using the param keyword, making your automation flexible and reusable. For example, a workflow might start a virtual machine in a specific resource group, and the workflow syntax helps us organize these tasks efficiently. The PowerShell ISE is especially handy here. It automatically compiles our workflow code and then lets us save the resulting artifacts, streamlining both the development and testing. Now, hybrid environments in Azure Automation is about extending our automation capabilities beyond the cloud, allowing us to manage resources both in Azure and in our own data center. The key feature here is the hybrid runbook worker, which allows us to run automation tasks directly on local services or resources, even if they're outside of Azure. By designating one or more computers as hybrid runbook workers, you can execute runbooks on premises, ensuring that your automation workflows reach every part of your infrastructure. These workers are grouped for high availability, and the agent on each machine initiates communication with Azure Automation, so it's going to securely pull down instructions and scripts whenever a runbook is triggered. This hybrid approach is especially valuable for organizations with a mix of cloud and on-premises resources, and there's no inbound firewall requirements, only outbound access over TCP 443 is needed, making the integration straightforward and secure. When a runbook starts, Azure Automation sends the instructions to the agent, which then runs the automation locally. This setup enables us to automate tasks like patching, configuration, and monitoring across our entire environment, whether resources are in Azure or in your data center. Hybrid management empowers teams to unify their automation strategy, streamline operations, and maintain control over complex distributed infrastructures. When automating cloud operations with Azure Automation, two powerful features help make workflows more reliable and efficient: checkpoints and parallel processing. Checkpoints act like save points in a workflow. So if a process is interrupted or encounters an error, it can resume from the last checkpoint instead of starting over. So this is especially useful for long-running or complex automation tasks where interruptions like a network outage or a server restart could otherwise mean wasted time and effort. We can set the checkpoints using the checkpoint-workflow activity, which creates a snapshot of the workflow's current state, making recovery seamless and minimizing downtime. Parallel processing lets us run multiple tasks at the same time. This is going to speed up operations and make automation more scalable. By using the parallel keyword, you can group commands together that should execute concurrently. For example, starting several virtual machines at once rather than one after the other. For even more control, you can combine a for each loop with the parallel execution, and that's going to allow granular management of which tasks run together or in parallel. And then that approach not only saves time, but it's going to ensure that our dependent tasks are handled in the right order and boost efficiency and reliability in our cloud deployments. Now let's take a look at desired state configuration. Configuration drift is a common challenge in managing cloud infrastructure. Over time, the state of our resources like servers, networks, and applications can change due to updates by people, automated processes, or external programs. These changes might seem minor, but they can introduce some serious security risks, such as open ports that should be closed, inconsistent patching, or software that doesn't meet compliance requirements. Drift can happen gradually and silently, making it difficult to spot until it causes problems. To combat configuration drift, organizations use solutions like Windows PowerShell desired state configuration, Azure Policy, and other integrated tools. These solutions help ensure that resources remain in their defined, secured state by automatically detecting and correcting deviations. By leveraging these technologies, teams can maintain consistency, improve security, and reduce the risk of unexpected issues in their cloud environments. This proactive approach is essential for keeping systems reliable and compliant as they evolve. Desired state configuration is a powerful approach to keeping your IT environment consistent and secure. With desired state configuration, we define exactly how we want our servers and resources to be configured, and this is called the defined state. Desired state configuration then ensures that your environment matches this state, automatically correcting any drift or changes that might occur over time. This means you don't need to worry about manual tweaks or unexpected differences between servers. Desired state configuration keeps everything aligned with your intended configuration, making your infrastructure more reliable and easy to manage. Desired state configuration works through a few key commands: the configuration, which are idempotent declarative PowerShell scripts that describe the desired state; resources, like PowerShell scripts that are compiled into .mof files to enforce that state; and the local configuration manager, or LCM, which is the client engine that applies to and monitors the configuration. You can implement desired state configuration in two main ways: a push mode, where you actively send configurations to your servers, or a pull mode, where the servers automatically retrieve their configuration from a central service. By using desired state configuration, we can eliminate configuration drift, maintain compliance, and ensure that every environment from development to production remains exactly as intended. Azure Automation State Configuration is a cloud-based implementation of PowerShell desired state configuration that makes it easier to keep your IT environments consistent and secure. With this service, you get a built-in pull server right in Azure Automation, so you don't need to set up or maintain your own. All of your desired state configuration artifacts, the configurations, resources, and target nodes, are managed in a single place, either through the Azure portal or PowerShell. This centralized management streamlines the process of applying and monitoring configurations across your infrastructure, whether you're working with a handful of servers or hundreds, spread across several different environments. One of the standout features is the ability to import reporting data directly into Azure Log Analytics. This means that we can send configuration and compliance data to our Log Analytics workspace for deeper insights and monitoring, and the general workflow involves creating a PowerShell script with a configuration element, uploading and compiling it into a MOF file, and then applying it to your defined nodes via the built-in pull server. Desired state configuration files are special PowerShell scripts designed to define exactly how your servers and resources should be set up. At the heart of every DSC config file is the configuration block, which acts as the main function and gives the configuration its name. Inside this block, you'll find one or more node blocks. These specify which machines, like VMs or servers, are being configured. For example, you might target a node called web server or use localhost to apply to the configuration locally. Within each node, resource blocks define the actual settings for the resources, such as installing specific Windows features or setting up parameters. This structure makes DSC configs clear, organized, and easy to maintain. With desired state configuration, you're not just writing a script, you're creating a blueprint for your environment. These configuration files are idempotent, meaning you can apply them multiple times and always get the same result, which is crucial for consistency and reliability. You can create and edit these files and the configurations in any editor like PowerShell ISC and save them as PS1 files. This approach lets you automate complex setups, ensure compliance, and quickly recover from configuration drift. By defining everything in code, you make your infrastructure predictable, repeatable, and much easier to manage when you're working with a single server or with a fleet of machines. When automating cloud environments, it's crucial to ensure that our configuration management tools support a wide range of operating systems. Azure Automation Desired State Configuration and PowerShell Desired State Configuration are designed to work seamlessly with many popular Linux distributions, including CentOS, Debian, Oracle Linux, Red Hat Enterprise Linux, and Ubuntu and others. This broad compatibility means that organizations can maintain consistent, secure configurations across diverse infrastructure, whether that's running on premises or in the cloud. By supporting multiple Linux versions, Azure DSC empowers teams to automate compliance, patching, and system setup for nearly any environment they encounter. Let's go to Azure and look at Azure Automation in action. To use Azure Automation, we need an automation account. So let's create one. After choosing Microsoft Automation from the marketplace, we complete the required fields, placing it in a resource group and giving our account a name. Azure Automation needs an identity that we can provide permissions to. And finally, we review and create. Now that our automation account is created, let's explore the resources in the account. Sample workbooks are provided to get us up and running. Inside the workbook, we see the PowerShell scripting. This workbook finds all of our resource groups and outputs the results. In the output section, we could observe our inputs, outputs, errors, logs, and any exceptions. In the shared resources section, we can set up schedules, find modules to import, import Python packages for Python workbooks, store credentials for use across workbooks, and connections we will reuse as well, and any certificates for access that we need. And lastly, any shared variables we might need. Finally, we can access desired state configuration using Azure Machine Configuration. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /MSLearn-DevOps. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch the other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.